So you remember we started with the design.
Yes, I remember that bit. Yeah.
Yeah, so we discussed about some of the relationships, and then we discussed about the primary key and the foreign key.
Yeah.
And the primary key is initially made to make a single, it's a kind of constant that allows a table to be any entry to be unique. Yeah.
Yep, I remember that. Yeah.
And as well as that is used to refer in the another table to create a relationship between two tables. Yeah, in order to avoid the excess data. So for example, like we discussed that instead of the order table could include the customer details as well. Yeah.
Yeah.
In
Yeah.
addition, in addition to the order details, however, by creating a primary key and foreign key between the customer and associating those keys using this referential integrity, you save lots of the uh, space and redundancy. Yeah, you reduce the
Yeah.
redundancy of the data. Now, so now some words highlights referential integrity. Means referential integrity is a relational database concept which states that the table relationship must be consistent. In other words, any foreign key field must agree with the primary key that is referred by the foreign key. How? So like the every key you are going to refer, like let's say 1 2 3, let's say like artist ID. Yeah, when
Yeah.
used is 1 2 3, and at any point you cannot use like a 4, number 4 artist ID does not exist in the other table.
Yeah. Okay.
Yeah, so
Yep.
referential integrity is violated, so you need to take care about this. So when you talk about the integrity, yeah, means reliability of the database. Yeah, whatsoever the rule has been defined, yeah, that needs to be obeyed. Yeah, if certain rules, the constraints are not being obeyed, it means the database is not consistent, and it's not in a good state. Yeah, so
Yep.
for the next is the domain integrity. Domain is basically the range of values. Yeah, range of values applied and explained in advance on particular values. For example, when you say that the column name is name and its data type is varchar 50, yeah, then gender must be one character, i.e. male or female. So the name is 50 characters, gender is, let's say, one character only. So if you talk about the domain integrity on the gender, yeah, the value of the gender, will you be able to write the female over there?
No, because you can only have one, can't you?
Yeah, yeah. So domain is basically the other name of the range of the value. Yeah. When you follow the range of the value within the database field, and then you say that it is uh, obeying the domain integrity. Yeah.
Yeah. Okay. Yeah, I get that. Yeah.
Okay. Now, entity integrity refers to having uniqueness among entities. One of data integrity. Data entity integrity example is having the primary key in each table. So, when you talk about a primary key, then it means you are talking about the entity integrity. When you talk about the domain integrity, means you talk about the values of a particular variable. Yeah. So these are just a number of terms used in the database terminology. Is that clear?
Okay, yeah, I get that, yeah.
There is another definition. Entity integrity ensures that there are no duplicate records within the table. So that's another definition. Yeah. So
Okay.
let us go little bit quicker. Foreign key integrity means declaring referential integrity or foreign key constant. Foreign key constants are used to check referential integrity between tables in a database. You remember we gave an example that the this condition should be followed. Yeah.
Mm.
So this is kind of the foreign key integrity as well. This is also known as a foreign key integrity, right?
Okay, yeah.
Now, the good interesting example in databases is normalization. Have you heard about this before?
Yes, I have, but I'm not entirely sure all the ins and outs of it. I've heard of it before. I've heard somebody mention it before.
Okay. So basically in relational database, we not only want to create a structure that stores all of the data, but we also want to do it in a way that minimizes potential errors when we work with the data. So potential errors, basically the errors, they are not the syntax errors, but they are the structural errors, like the structure of the tables you create. Yeah, that you have to check whether the number of tables and number of columns you have defined, would those columns remain fitted well or not. There is a lots of possibility. For example, if we ask you to create a database, yeah, you propose with, for example, number of 5 tables, yeah, along with number of 5 fields, yeah, you created the relation in between, yeah, then probably somebody, an expert, could advise you maybe 7 tables instead of 5, or maybe 3 tables instead of 5. Is that possible?
It could be, yeah.
I mean,
Yeah.
your database will, for example, if you are new, you don't have an experience of creating, a perfect structure of the database, then probably you would do mistakes. Do you
Yeah.
agree?
Yeah, absolutely. Yeah. Yeah.
And
The only problem is it's too late, isn't it? It's very difficult to go back and change, isn't it?
no, we are not in the phase of the initialization. We are in the phase of database design at the moment.
Okay.
Yeah. So in the database design, you created 5 tables, and even you created the 5 tables in the first instance. Yeah, you will have to make sure that there shouldn't be any structural problems.
Okay.
Okay.
Yeah.
So the database developers or designers or architects, those who thought that there would be definitely certain problems in the database creation, and they have listed those problems in advance, which can occur in any ways. Yeah.
Yeah.
So
Okay. Yeah.
the default language for accessing data from the relational database is SQL. So when you create a database, you have the database, you want to minimize the errors, yeah, and you want to access this through the SQL, and the SQL is used to manipulate the data in following ways. Normally, what you need to do, you insert the data, you delete the data, and you update the records. So what happens when you insert the data? Certain problems can happen. When you delete the data, certain problems can happen. And even when you update the data, there can be certain problems. So what those problems can be happen? So they have given certain names. It's called the insert anomaly, delete anomaly, and update anomaly. Yeah. What is
Okay, yeah.
this? This refers to the situation when it is impossible to insert certain types of data into the database. Like, you created a table, yeah, and the name of the tables, for example, a column is, based on, it only allows you to insert, let's say, one field, and you have come up with the three fields, yeah. So let us look at generally, you will have a problem of insert anomaly, deletion. The deletion of data leads to unintended loss of additional data that the data that we had wished to preserve. So now let us try to give highlights. What problems? When you are trying to insert, you will have some problem. When you are trying to delete something, then unintentionally something else is deleted. Yeah. Then update anomaly. This refers to the situation where updating the values of column leads to a database inconsistencies. Yeah. So superficially, can you just imagine that the two are common? For example, if you wanted to delete one thing and it made the problem in other things. Have you ever noticed this?
Yeah, I've seen that before, where somebody has done that, and yeah, I didn't understand how to fix it though. I didn't fix it, but yeah,
It happens.
yeah, it does. Yeah, it happens. Yeah.
Yeah, like when you install online in the web development, like MySQL, create some, you are trying to insert the data, then it says no, the same data or table name already exists. When you deleted one table, then it deleted other relevant and important tables as well. Yeah, you
Mm.
didn't know about it. And when you try to update, then it didn't allow you to update something. So these things really needs to be considered. And the database management system, they have advanced, they have already told you in advance. Is it good?
Yeah.
Yeah. So now let us see that what it is. To address these three problems in previous slide, we go through the process of normalization. So in order to avoid these problems, yeah, we start this problem using the normalization. We go through the normalization process. We increase the number of tables in the database. Yeah, like I gave you an example that possibly you propose 5 tables, and after the normalization you are required to create 2 more tables in order to make it perfect. Yeah. And then while decreasing the amount of data stored in each table, yeah, there are several different levels of the database normalization, but let us discuss three of them at the moment. So when you say that you have normalized the database, you say first normal form, second normal form, third normal form. Yeah. So
Okay.
let us
Yeah.
see how it works. When you say that the a database is in first normal form if it satisfies the following conditions: that contains only atomic values, there are no repeating groups, and atomic value is a value that cannot be divided. For example, here if you have a look, product ID 1, 2, 3, 4, 5, color red, green, yellow comma blue, red, price is 15, 23. Now look at here, that color, the product ID has two colors. Yeah, red and green. Product ID 1 has two colors, red and green. 4 has yellow and blue. First rule is that your table should only contain atomic values. Yeah. So if you have this situation, then what you need to do, you need to create additional table, yeah, with colors, yeah, like product ID 1 has red, product ID 1 has green, 2 yellow, yeah, and 3 green, 4 yellow, 4 blue, 5 red. Now you can have a look that every, you have created an additional, table so that you can fit, the atomic value here.
Interesting. Yeah. Okay.
Yeah. No
Yeah.
matter if it is repeating here, yeah, but you have to make sure that the even what I would say, like he has repeated the product ID 1 and 1. Probably I would have written like a product ID 1 is red, 2 is green, 3 is yellow, 4 is green, 5 is yellow, and something like that, and using here.
Yeah. Okay.
Did you notice that they have used the product ID with the two colors? One has got two colors.
Yeah.
Yeah. Programmatically, they could know that one product can have more than one colors. Yeah. And this, maybe product ID will not be a primary key.
Right.
Yeah.
Okay.
Yeah.
Yeah. Yeah.
Yeah. So this could be a variety. Probably the product ID could have, let's say, 100 colors. Yeah.
Mm.
But what they are trying to say that a color field could only be atomic. One field could not be able to hold more than one field.
Yeah. Okay.
Okay. So when
Yeah.
it comes to the situation, then you are using more than one field in a column, then it means your database is not in first normal form. So initially you create additional table and remove and make it atomic. That is called the database in the first normal form. So is that clear?
Yeah. I get that now. Yeah. Okay.
Yeah.
Yeah. Yeah.
So
Yeah.
that's basically a kind of, the very basic mistake. A novice, a new beginner, might be thinking, that if one product has two colors, then he or she might be using, or storing the red and green into one. Yeah. And but the database, those who have given us the database theory, then they have identified this first normal form as a mandatory.
Yeah. Okay.
Okay.
Yeah.
Now, second normal form. Second normal form says a database is in the second normal form if it satisfies the following condition, that it must be in the first normal form first, yeah, and then all non-key attributes are fully functional dependent on a primary key. All non-key attributes are fully functional dependent on a primary key. And now basically theoretically, if we would be thinking on theoretically, it might be difficult, but let us go to the example directly and then you would understand. Yeah.
Okay. Yeah.
Now if you look at here, that store ID 1 is Los Angeles, 3 is San Francisco, and in this table, this is a purchase table. Somebody wanted to store the customer ID and store ID. However, what they did basically, they could possibly just store the store ID instead of repeating the store detail in every table.
Okay, yeah. So they've put in an extra bit there for no reason.
Yeah, like Los Angeles is, used, maybe 2 times here. But
Yeah.
for example, the store of, let's say, Los Angeles was used 100 times. Yeah. Then purchase table, it was not good enough to repeat the Los Angeles 100 times in a purchase detail. Yeah. What they tried is, sorry, the table, they created a store table. They allocated store ID 1, 2, and 3, and the purchase table they did, a purchase table with customer ID and the store ID.
Okay.
Yeah, like every time, for example, you are an employee. Yeah, if you are given an employee number, yeah, then an employee number is sufficient to process every of your data. However, every data, let's say monthly or salary basis. However, your rest of the details would be associated with your file.
Okay.
Yeah, and so that's normally called the second normal form when you uh, let's say that all non-key attributes are fully functional dependent on a primary key. Previously, uh, here Los Angeles was dependent on store ID, but this store ID was not the primary key. Was it primary key?
No.
No, because this table contained repeated store IDs. However, when you create, for example, when you created this store table and you uh, defined the primary key like a unique key on the store ID, then every the non uh, every non-key attribute now became the dependent.
Yeah. Okay. Yeah. Yeah. It becomes dependent. Yeah.
So non-key attributes, they have become a dependent on the primary key now. Yeah.
Yeah.
Now
Okay.
the third normal form. Yeah. A database is in third normal form is only if it's satisfied that it is in the second normal form first. And if it is in the second normal form, then what is the condition of the second normal form? Then it must be in the first normal form and the second normal form conditions. Yeah.
Okay. Yeah.
So the third normal form says that it should be in the second normal form. It means it did the first normal form things and the second normal form things as well, and there is no transitive functionality dependency. Transitive functionality dependency means we have the following relationship in the table. A is functionally dependent on B, so price is dependent on, sorry, price is dependent on genre type. Let's say there's kind of book details, and let's say gardening, and the genre type is dependent on the genre ID. Yeah, so A is dependent on B and B is dependent on C. Let's say, for example, yeah, so let us see that how this is you know going to be transformed into the third normal form. Genre type is dependent on price, genre ID. So this repetition, like number 2, is basically removed.
Okay.
Yeah. So until here, yeah, until this table, this became uh, the second normal form, and in the third normal form, what happened? The genre ID is depending on the book ID now.
Okay.
Yeah.
Yeah. So yeah. So yeah. Okay. Yeah.
So that's basically the third normal form. And probably that's not only the one example, probably there might be some easy examples. However, there are possibilities that you can find lots of examples on the third normal form, and that's not only the third normal form, there are more forms as well. Yeah.
Okay. Yeah.
So they have given the names to those complexities and accordingly. So we are just trying to discuss up to third normal form here. Yeah.
Okay. Yeah.
So now that was about the understanding of the first normal form, second normal form, and third normal form. And obviously these theoretical bits are always helpful. You can read, and but from the pictures it's quickly understandable. Yeah.
Yeah.
Now some more the topics to be discussed, like a data administration is done by the data administrators, use specialized software to store and organize the data. Role may include capacity planning, installation, configuration, database design, migration, performance monitoring, security, troubleshooting as well. So well-known, activities done by the data administrators. Yeah.
Okay. Yeah.
Skills, the DBA skills and responsibilities, the list of skills required to become database administrator, like a communication skills, knowledge of database theory, knowledge of design, the knowledge about relational database management system itself, knowledge of structured query language, SQL, general, blah 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 blah. Yeah, is it okay to go ahead?
Yeah. Go ahead. Yeah, that's fine. Yeah.
Furthermore, responsibilities: installing and upgrading the database server, allocating system storage, modify the database structure, enrolling users, ensuring compliance with the database vendor license agreement, controlling and monitoring user access, monitoring and optimizing performance, planning for backup and recovery, maintaining archive data, backup and restoring, contacting database vendor, generating various reports. Yeah,
Okay.
these are
Yeah.
interesting things. Yeah, like responsibilities, when we say that database administrator is doing nothing, but they are responsible for many things: installation, modification, creating users, controlling, monitoring, even reporting. Yeah,
Yeah.
it looks like that they are doing nothing, but they have lots of things in list to do.
Yeah. That's a bit like my job. It looks like I'm doing nothing, but I'm not.
Yeah. So you do database administration in your company.
I do a little bit. I'm responsible for the backups, and also I'm responsible for any sort of upgrades.
Yeah, that's
But the only thing I don't do at the moment really is reporting.
yeah. So people would be thinking, that it's very easy to do the, backups and upgrading. However, it's a very responsible job. If you do anything wrong, then you would be responsible.
Yeah, absolutely.
Right. So the learning outcome 2 that we left, in the middle is complete.
Okay.
Now, learning outcome 3 is scheduled for today, is in, I have put in the 3 parts. So probably we start now.
Yeah.
And now let me catch up with the highlights of the uh, learning outcome. Be able to design a database system. So in the learning outcome 2, we were talking that understanding of the database design. Yeah. And
Yeah.
here certain steps needs to create a database design system, and obviously this might be little bit different from the session, like we may not be able to create the design here. However, the learning of the assignment scenario would require you to create the database itself. Yeah. So relational database design, obviously based on the design fundamentals, logical versus physical design, and database documentation would be discussed. Stakeholders for the database documentation and database evaluation like performance evaluation, benchmark, verification, and validation. Yeah. So
Okay, yeah.
let me go ahead one by one. So a well-designed database is a prerequisite for a fast data retrieval and updates. That's true. If the database is designed well, then you can, get a faster database retrieval. Before you build the tables and other objects that will make up your system, it is important to take time to design it. A good design is the key stone to creating a system that does what you want it to do effectively, accurately, and efficiently. The basic steps in designing a database system are to determine the purpose of your system. For example, this is most important, that why you creating, to determine the number of tables you need to in the system. Yeah. To determine the fields you need in the tables, identify fields with a unique values, determine the relationships between tables, to refine the database, to add data and create other system objects. So is that clear? The number of
Yeah.
things simply. Yeah.
Yeah, that's
So
clear, yeah.
maybe, by default, when you are creating the database, then, probably you could start with, on your own style and by picking the things from your mind. However, if you have list of these things, then you would never miss anything, which could be left over.
Mm.
Make sense?
Yeah, yeah, absolutely. Yeah, I can see how important that is.
Yeah. And probably this list could be more. Yeah. Now, when you create a database, you deal with the entity relationship diagram. Yeah. So it won't be the case that you are directly implementing the database, but you would be referring to the entity relationship diagram, how the entities are related to each other. Basically interchangeably.
Hello?
Hello, yeah. So
Uh,
the voice is back now.
Okay.
Yeah. Sorry, I still could have not know the reason, but it happens, every 30 minutes or 40 minutes. Not sure what's the reason, and but let's go ahead. Yeah.
Yeah, okay, yeah.
So so I was, trying to say that people say I have designed this car. Normally, when they talk about the implementation, but designing is different from the implementation. Do you agree?
Yeah, absolutely, yeah.
Yeah. So in the second phase, you design your database by defining the entity relationship diagrams. Yeah. of the database. So how the entity relationship diagrams look like? Basically, you are obviously having the entities and their relationships and the attributes. Probably you remember, from the previous slides.
Yeah. Okay.
Yeah. Like,
Yeah.
we created the customer and their relationships, one to many, many to one, and those things. Yeah.
Yeah. Yeah. Okay. Yeah.
Yeah. And those
Yeah.
were the entities along with the attributes.
Yep.
Yeah. And the relationship in between them. But those entities were given just, the names. For example, this is an entity, this is an attribute, and that's, the relationship. However, the entity relationship diagram should use the number of, symbols here.
Okay.
Like, excuse me, like entity is represented this rectangle, weak entity represented via, the double rectangle, the relationship via this diamond, the identifying relationship with double diamond, this has some, role, the oval maybe attribute, and something written under the, underline is key attribute, weak attribute, blah blah blah. The one is mandatory, one is one, the participations, and then, their occurrences, recursive relationship, optional, many to one, many to one, then many to many, many to one, and, zero more, something like that. Do you get this?
Yeah. Yeah. I'm getting that. Yeah. I can see that. Yeah.
Yeah.
Quite interesting. Yeah.
Yeah, and that's a language complete.
Yeah.
Yeah, and you must have heard about the UML.
No, I've never heard of that before.
You haven't heard about the UML, Unified Modeling Language,
No, I've not heard of that before.
is it?
No.
Okay, that's very, UML is the Unified Modeling Language, and that was, introduced by three, and three proposers, Jacobson, Ramba, and Iver. Yeah,
Okay.
and though they basically, probably, if you could recall that software process, yeah, software development has come through certain, ideologies, methodologies, like, they say you design a software according to the waterfall model. Yeah,
Okay.
like
Yeah.
step by step. Somebody said, the you design the software according to the spiral model. So out of, coming, passing and testing these theories, yeah, the when you want to create a design of software, yeah, using any particular diagrammatic language, UML is one of the most useful, popular, and object oriented modeling language,
Okay.
right? So
Yeah.
the for databases, you specifically use the ERD, entity relationship diagrams, and these diagrams are very specifically defined for the database entities. Yeah. However, for the system analysis and design, have you heard about? You must have heard about the system analysis and design.
Yeah,
Yeah.
I've heard of that before. Yeah.
Yeah. So when you analyze the system, you write the requirement, and when you design the system, then your design is illustrated by the diagrams. Yeah.
Okay.
So
Yeah.
the best diagramming is now basically the unified modeling language. It has some artifacts like a class diagram, association diagram, sequence diagrams, you know, collaboration diagrams, and it has certain tools as well, like a rational rows you create and code and do the reverse engineering by using these diagrams and the tools. Yeah.
Yeah.
So
Okay.
yeah, so that's the the introduction of the UML. UML is a complete study. Yeah, and you normally use that as well. So in addition to the, like, these rules have been advised for the databases, and when you want to analyze the system, then you can use the UML as well. Probably in the next units, there is definitely the discussion of the UML as well. Yeah,
Okay. Yeah. Interesting.
that's
I've made a
interesting.
note. Yeah, I've
Yeah,
made a note of that. I'm going to look into it.
definitely have a look. And
Yeah.
even there is a certification as well.
Oh, okay.
Like the programmers work under analyst. Yeah,
Yeah.
those who analyze the system, they are much more on the higher level, and what they do, they only do the object oriented analysis and design certifications. Yeah, they study in depth, and they are the bosses.
Ah, right. Okay.
Yeah,
They're the they've got the big pay packet.
yeah, and obviously they would be responsible for the architecture as well.
Mm.
So then there is a data flow diagram. The question arises that in those entities, how the data will flow, right? Like user is making orders through the process order entity. Yeah, the process
Okay.
order entity would trigger to the invoices entity. Yeah, obviously the process order would have the attributes, invoices would have attributes, and then the orders entity would be created. The user would be another entity, and then the entities, fulfillment entity, shipment, ship products, and collection payment. These are the entities which are being interconnected, and their flow is you know uh, drawn here.
Okay.
Yeah, so like there are lots of case studies available, and they are well known case studies like orders. Yeah, in maybe in the banking, like the students or enrollment, they have a well known data flow diagrams. Yeah,
Yeah.
so
Okay.
data flow diagrams, we can commonly find those on the internet, and can understand, like that from the user, the data would, like the flow would proceed initially into the process order. User would really uh, would be interested to process an order. So initially it would start with the process and order. Then order would require the orders table, for example, and then need to generate the invoices, and the invoices related with the payment. The order would be related with the user again, and user, the shipment of the product would be related with the user, that where it needs to be done, and the ship products would be supported by the fulfillment table. And overall, the user is getting the shipment, as well as paying the payment for the order via the processes. So you can really have a look here that there is a connection, that possibility of the data is being uh, flown in between.
Okay.
Yeah, so
Yeah.
you should very much clear that which table can give the data to which table or entity.
Yeah. Okay.
Yeah. Obviously the entity becomes a table based on the number of attributes at the end, isn't it?
Yeah. Okay.
Okay, so that's about the data flow diagram. And there is obviously the certain more information about the data flow diagrams. Some of them called the external entity. You show the process, you talk about you represent them as a data store, you represent them as a data flow. So like these symbols: external entity, process, store, flow. If we come here,
Oh
then
yeah.
arrow is showing like a flow, yeah, and
Yeah.
probably the circle is process, and this is store, like orders. This is kind of a store here.
Yeah. Okay. I get that now. Yeah.
One is a store, and this may be the external entity. Like the external entity is just giving the information, and somehow uh, some of the artifacts are used here. But however, there would be definitely from time to time there would be more data flow diagram symbols as well.
Hmm.
Yeah. So
Yeah.
that's just the definition. The core, I have listed here the important the data flow diagrams. Yeah. And
Yeah.
probably when you enlarge this data flow diagram, then some of the the entity relationship diagrams, yeah, some of the symbols from the entity relationship diagram might be helpful. Yeah. But
Yeah.
overall the data flow doesn't have anything extra. Only it shows that from where the data is going to where.
Okay.
Yeah.
Yeah.
So you should be able to know that you know who is sending the data, and who is storing the data, and in which direction the data is being sent. Right. Hello.
Hello. Yeah. I'm still here.
Yeah.
I was just looking at that diagram with
Yeah.
what you said.
Yeah. So the directions are important: who's storing the data, which one is the entity, and where the process is going on. Yeah.
Yeah. Okay.
So now database development review. Yeah. So we start with a design review. Basically, when you really start with the database design, yeah,
Yeah.
then you to review the development. And how you can review the development is basically the reviews are an important aspects of system development lifecycle for the database applications. It is during the design review that all aspects of the database and application code are reviewed for efficiency, effectiveness, and accuracy. So you are in a the implementation phase, and which also includes the review. So your review provides the efficiency, effectiveness, and accuracy. There are 7 basic design reviews for the database application. What are those? Those are conceptual design review, logical design review, physical design review, organizational design review, SQL and application code review, pre-implementation and post-implementation review. So let us see how those are reviewed. When you say conceptual design review, that's the first phase. Yeah. Purpose of this review is to validate the application concept. This involves a presentation of the statement of the purpose as well as general overview of the desired functionality that will be provided by the application. So it should be the case that whatsoever you want to create a database, you should have a first instance of the conceptual review, that whether that is the concept or that is the requirement of the database really or not. Make sense?
Yeah. Okay. Yeah.
Your inception, your concept is valid or not. Yeah.
Yeah.
Then logical design review, that's the second phase. This should be conducted when the first cut of the original model has been completed. A thorough review of all data elements, descriptions and relationships should occur during the logical design review. This says that has the logical model been thoroughly examined to ensure that all of the required business functionality can be achieved based solely upon the model. So you are going to make a logical model. You are going to review the logical model, and then is the model in the third normal form. Yeah, at least in the third normal form. Yeah, have all of the data elements required for this application been identified? Have the data elements which have been identified been documented accurately? Have all of the relationships been defined properly? Makes sense?
Yeah. Okay. Yeah.
So logical review is related with the logical structure of the database.
Okay.
Yeah.
Yeah. Yeah.
Conceptual review allowed you to at least validate your idea of creating the database. Yeah.
Yeah.
Then physical review. Physical review is basically the third review. It is the it is this component which most DB developers associate with the design review process. So still some of the databases, they the developers, say that the physical review is still the design.
Hello.
Yes, you're right now. Hello.
Hello.
Yes, I think now the voice is fine.
Yeah. Okay. Yeah.
Okay, so the third review is the physical design review. Yeah, this
Hmm?
is where the database reviewed in detail to ensure that all of the proper design choices were made. In addition, DA, data administrator and database administrator should ensure that a proper translation from the logical to physical was made, including conformance to standards, mapping to appropriate database objects, and performance tweaking for physical database management system issues. So at the design level, still some of the DB2 developers, they say that it is the design review. Yeah, you haven't created actually database, but still they think that it is the design review. Then is that clear, the physical design review?
Yeah.
Like the first review is the conceptual review. We reviewed whether the idea and is good, should we go ahead or not. Okay. Then
Yeah.
in the logical review, what we discussed is the has the logical model thoroughly examined, is the model in the third normal form, and all the attributes are defined, all elements are defined, all the relationships exist. Yeah. The
Okay. Yeah.
physical review is basically the next variant to the design review, as well as that is related with creating the database in the database as well, like in
Huh?
coding directly. Yeah.
Yeah. Okay.
But they still look at like the design review as well.
Okay. Yeah.
Yeah, just
Yeah.
keep in mind it says it is in this component the DB2 developers associate with this design review process. So they associate with the design review and they see that how whether they are fine, and as well as they create the things physically in the database.
Okay. Yeah. I've got that now.
Yeah.
Yeah.
So
Okay. Yeah.
they make sure that everything has been done very well into the design review or not as well. Okay.
Yeah. Okay.
The organization design review, smaller in scope but no less critical, is the organization design review. This review addresses the enterprise wide concerns of the organization with respect to the application being reviewed. Common review points include how does the system interact with the other systems in the organization. So the database is in front of you, which has come through the conceptual view, design view, physical view, and you need to review according to the organization whether it is suitable for the organization or not.
Okay.
All the concerns of the organization have been addressed or not. It shouldn't be the case that it is not user friendly for the particular organization, isn't it? Is that
Yeah.
possible?
Yeah. Yeah. It's got to be it's got to be right for the users, isn't it?
Yeah. Then SQL design review. Yeah. SQL design review, basically the SQL is, uh, structured query language and responsible for interacting with the database and must occur for each SQL statement prior to production turnover. The SQL design review should consist of the following. An explain should be run for the SQL statement using production static. The plan table should be analyzed to determine if the most efficient access path have been chosen. Basically, the SQL, you created an SQL, then its design can itself be reviewed using the SQL tools.
Okay.
Like an explain is a command which would give you the statics. Plain table should give you the most efficient paths across. Yeah. Then every aspect of the database can be reviewed using its tools. So it's advising that you review the SQL as well.
Okay. Yeah, interesting.
Like that's a kind of aspect. Yeah. That whether your database is able to query in a proper way or not.
Okay.
Like it should be easy to query. It shouldn't be the case that you don't have a way to inquire the database.
Hmm.
Probably some of the fields you didn't define well and you have no way to retrieve the data. Is that possible?
Yeah. I mean, yeah, the thing is, if you can't query for
Yeah.
the data, and it's almost useless, isn't it? You can't see the data, you can't query it,
Yeah.
then you may as well shut the database down.
Yeah.
It's
Yeah.
one of the most important parts.
Yeah, exactly. So there are certain, queries like explain, plain table, something this, and also it depends on the language as well. Yeah.
Okay.
If the communication language is strong enough, then you would be okay. If not, then you will have a problem.
Just a question.
Yeah.
How would you get round that if you can't query it, if the commands don't work? How do you fix that?
Yes, that's a good question. What
Yeah.
happens that you need normal, you might have seen, an object ODBC.
Yeah. Okay. Yeah, I've heard of that. Yeah.
ODBC is a basically bridge, and we normally create, in the control panel.
Ah, right. Okay. Yeah. Yeah.
Yeah,
Yeah. I know. Yeah. Yeah.
yeah, that's a kind of, when you really want, for example, if you installed, Microsoft SQL Server in your computer, yeah,
Mm.
then it became a server, and in order to create a communication with the server using the front end, yeah, you created a driver, yeah, for example
Yep.
ODBC, or you
Yeah.
created a driver for the JDBC, Java Database Connectivity, yeah. And now your question is, how would you know that a particular the uh, connection to database goes well or not? What was your question?
My question is, if it went wrong, how would you fix it? But I think you've answered the question. I guess
Yeah,
if the ODBC driver connects up properly,
yeah,
then that's going to work, isn't it? If that doesn't work,
yeah,
if that doesn't connect up, then it's not going to work. And I've had that before where it's not worked
yeah.
because I've entered the wrong details or I've got the wrong settings or something.
No, still not. You got my answer as a full, but let me answer it more. For
Okay, yeah.
example, the capability of the OTBC driver, yeah,
Mhm.
is a connection of pool. For example, if you want to inquire, if you want to access the database, for example, 100 tables in a, in one go, yeah, then probably the limitation of the database base, the efficiency of the SQL can, make you a problem.
Okay.
Yeah.
Hmm.
Why it will give you a problem? Probably the nesting, you might have, the use the nested queries. Yeah. Like,
Okay, yeah.
yeah, like a nested query, you want to say, I need a employee who worked in 2000, 10, and he was from, the Wales, and he was, 20 years, not above the age of 20 years. For example, you created the too much nested queries, yeah,
Hmm.
and those requirements were really necessary for the organization, yeah.
Hmm.
And at some point, your database, was not organized in such a way that all the tables could be queried at one time,
Okay.
yeah. And
Yeah.
in addition to this, your SQL, and obviously the database was designed, in table, and the capability of the SQL would depend on the programming language as well. That,
Okay, yeah.
and the complexity of the query, if the complexity of the query is processed, in an efficient time, yeah,
Hmm.
then it means you have done very well.
Yeah,
If
okay.
the complexity is not, achieved, the complex queries are not executed, so quickly, it means your SQL design review is, you know giving you a kind of trigger that you need to have an efficient SQL and the
Yeah.
structure.
Okay, yeah.
So you created an structure, and your structure needs to be queried using SQL, so that everything should be, efficient, and the efficiency of the SQL, the retrieval of the data, is dependent on the programming language as well. Yeah, like this
Yeah.
paragraph, every program should be reviewed to validate that in inefficient host language, COBOL, Java, etc. constructs were not used. In addition, efficient SQL implemented inefficiently within the loops should be analyzed for its inappropriateness. All dynamic SQL should be reviewed whether it is embedded in an application program or to be run through a report or query tool. So that's not only the case that the programming tool is inefficient, but even your logic of retrieving the data can also be inefficient.
Okay. Yeah. Yeah.
Normally what happens, when you retrieve the data, when you say that select all from table this, then how really it does? In this command, what they do, they run the loops inside. Yeah, for I is equal 1 to n. Yeah, then by one those loops are executed. Yeah, so the
Okay.
SQL review is basically the programmatically review, but obviously it is given to you in the form of the uh, some automated process. So only the recommendation is that you should go through. Okay.
Hmm.
So really depends that which tools are given, like an explain, plain tables, and these things tools may be used. Yeah.
Okay.
So
Yeah.
the design review also includes the pre-implementation design review, like previous phases, as well as it consists of overall review of the system components to the implementation. Loose ends which exist with the previous 5 phases should be cleaned up, and final quick review of each application component should be performed. And the participant should include the you know these are the previously you know terms. You leave it, don't need to go into the detail. Yeah. And the post implementation review is basically the final phase of the review, and this is necessary in order to determine if the application is meeting its objectives. So in a simple nutshell, yeah, the when you did the pre-implementation, it means you did the 5 phases. Is that clear here?
Yeah.
Yeah. And in the post implementation, you check the application is meeting its objectives in the
Yeah.
best performance.
Yeah.
Yeah. So that's it.
Okay.
So let's catch up with this design review. Pre-implementation, you did the five reviews. In the post implementation, you check with the performance and the quality, and you remember how the quality is measured.
Yeah.
Like a non-functional, for example, if you are accessing 100 records, then you need to see that 100 records are achieved in how many seconds. Let's say 30 seconds, 50 seconds, and then probably sometime the databases, you have got a database of uh, 10,000 employees. Yeah.
Hmm.
And
Yeah.
if you
Okay.
wanted to search one employee, yeah, then one employee out of 10,000, then probably the database will need to search 10,000 employees, and you would know the record maybe after 3 minutes.
Yeah. Yeah. It wouldn't take so long, would it?
Yeah, like 3 minutes, maybe the database could retrieve to you the answer after 5 minutes.
Yeah.
Yeah. So
Yeah.
that's typically the performance.
Yeah. That's
Yeah.
very. The performance is a very important part, isn't it?
Yeah. Yeah. So that's a post implementation design review. So you have different ways, and you can know by testing the database. And pre-implementation are the 5 phases, like these SQL review, and the physical design review, organizational review, logical review, and conceptual review. Yeah, is that clear?
Yeah. I'm
Okay.
going to do some reading up on each bit, but yeah, I get the general idea.
Yeah, you got a oh yeah, we were discussing generally, and
Yeah.
so they are most important. And now let me see. Oh, this one was a part one. Quickly, let me complete the part two and part three as well. Yeah, in next 10 minutes.
Okay. Yeah. If you think we got time, yeah.
Yeah, we have still 10 minutes, and we need to complete. They are small. I have just split it to give it separate importance. Now, database documentation. Yeah. The documentation, documenting a database during its development is the best practice to ensure that the organizational schema, data, objects, and other related information are captured for future reference. Yeah.
Okay. Yeah.
So this includes the data dictionary. Yeah.
Yep.
Database administrator guide, database architecture documentation, and database functional specifications. So basically, we are here database documentation, stakeholders for database documentation, documentation types, and we'll discuss the evaluation performance, evaluation benchmarks, verification, and validation. So in the part two, the documentation is being done.
Okay.
Yeah. So most of the time, have you heard about the data dictionary?
A data dictionary.
Yeah.
Yeah. Is it It's almost like all the key points, isn't it, for the data?
No. That is
No.
basically entries of each and every entity existing into the database, like
Okay.
like a kind of full fully full documentation of your database design,
Okay.
like architect. The database documentation serves multiple audience including database architects, developers, administrators, so anyone, even at the user or the architect programmer, they will refer to the data dictionary. Yeah, so that comes
Yeah.
to the database documentation. And that includes, for example, if you have one data, for example data element like a student, then it will have a number, the data element name, short description, security classification, listing, field names, blah blah blah. And simply, you know uh, technically, for example, if you have a table, then what do you expect from the table? It should have a name. Sorry, I skipped one or two slides. They are not important. I mean,
Okay.
we can skip here. If you talk about the table, then a table will have a name, a database table or owner name, data element column names and details, key order for all elements, database index information, technical table organization, duplicate rows, data element list, which looks like this. Uh, this,
Okay.
like select asterisk from user tables.
Hmm.
Now, this is a valid command in the database. If you want to know that how many tables in the database are, like a student is a table name, table space name is users. Yeah. So students are under the users, cluster name, blah, this, IoT name, status valid, blah, 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 blah. So if you could have a look here, the have you done any, the have you worked with the MySQL?
I've done a little bit, a couple of little queries around when we have to find locks and stuff. So I've used a
Yeah.
little bit of it, but I haven't done an awful lot.
So, uh, for example, if you are using the SQL, yeah, SQL is basically, the uh, structured query language. You play with, the database,
Yeah.
like like command prompt. Have you?
Hello? Hello?
Hi, you're back now. Yeah,
Yeah,
your
I
voice
can hear
is
you
back.
now.
Yeah. So you must have used this, command prompt. Yeah.
Yeah, absolutely, yeah.
Yeah. So uh, what we do, like directly page wise. Yeah.
Yeah.
Directory, for example, we play with DOS, the disk operating system. You must be aware with all of the commands. Yeah.
Yeah, I've done all commands and
Yeah.
PowerShell as well.
Yeah. Then similarly, the data dictionary is created. It can be accessed through the SQL, right?
Hello?
Hello. Yes.
Hello?
Hello. Yeah.
Yeah, I can hear you again now. You were echoing?
Yeah. I don't know what happens. So can you see the screen now?
Yeah, I can. I don't think I'm not sure if the screen has changed though, because you're still at the C prompt, CD.
Okay. I'm on the browser now.
I can still see the command prompt.
Is it?
Yeah.
Okay. 1 second. So, okay, let me tell you, the bit more about the data dictionary.
Okay.
Like we play with the, all directory structure of the computer with the disk operating system, like a directory, select all, delete, copy something. You must have used those, yeah.
Yeah.
Similarly, the SQL has commands which can, retrieve the data dictionary of the tables. There each and every information about the tables.
Okay.
Yeah. So the point we are discussing is database documentation. So database documentation we discussed like previously that obviously the documentation would be a detailed, information about the name of tables, their fields, and their sizes, and everything related technically. Make sense?
Yeah. Okay.
Yeah. and
Yeah.
and more specifically, the SQL has the option capability to obviously to create as well as to show you that the information. Make sense?
Yeah. Yeah. Definitely.
Okay, so I was trying to show you the data dictionary commands in the SQL, but the computer is a little bit hanging. I don't know why. So is data dictionary clear to you?
Yeah, yeah, I get the idea. You can discover the tables and discover the database using the commands.
In the commands, like you really capable been be able to know the structure of the table and the details of the table, that how the spaces and these things have been allocated.
Yeah.
Yeah. So
Yeah.
that was about the documentation, and obviously there are certain advantages and disadvantages of the data dictionary. Advantage is that if you have a data dictionary, then any programmer can understand it well. Yeah.
Okay. Yeah.
But
Yeah. Yeah.
disadvantage is that if you are explicitly creating the data dictionary and nobody has to use it, yeah, and then it's a disadvantage. It will cost you a lot.
Yeah. Okay. Yeah.
Yeah. So are you able to see the slide?
No, it's still on the DOS window.
Okay, that's fine. So it only discuss the advantages and disadvantages of in the dictionary. I explained to you, and how the data dictionary look like. I gave you an example that it gives the idea of, not idea but exact, the storage structure and naming structure whatsoever it is about the database.
Yeah. Okay.
Yeah. And
Yep.
that was about the part 2 of the database. Oh, sorry, part 2 of learning outcome 3.
Okay. Yeah.
Yeah. And learning outcome 3, the part 3 is basically on the database testing.
Okay.
Yeah. Do you access the Moodle from the our Moodle?
I go on there every so often to get the assignment templates and stuff. Yeah.
Yeah. Yeah. So let me give you the some idea about the third part as well. Yeah. So that's
Yeah.
based on the database testing, and testing is discussed generally, that whether you need to do the structural testing, functional testing, and the its advantages and disadvantages have been discussed. Let me give you a kind of the two types of the testing
Okay.
in verbal. Yeah.
Yeah. Yeah.
When you say like black box testing,
Yeah.
yeah, do you know what is the black box testing and the white box testing?
No, I don't.
What happens when you test the whole system? You call it as a black box testing. You don't know that what is inside. Yeah. And when you test the each and every component individually, yeah, you are basically testing the white box testing.
Okay.
Yeah.
That's interesting. Yeah. Okay.
So if you are required to do the white box testing, it means you will be testing each and every module. Yeah.
Yeah.
So
Okay.
yeah. So there isn't anything more practically defined into the third part. Yeah. But a discussion about the black box testing and white box testing, that's the one topic. And
Okay.
another is the functional and non-functional testing. Yeah. So
Okay. Yeah.
the functional testing is basically the black box and white box testing, because you are testing the technically, right? And non-functional testing is basically the quality of service testing.
Okay.
Do you remember the difference between the the functional requirement and non-functional requirements?
Yeah, the trying to think now. Was it the non-functional requirements was what the system was actually going to do,
Okay.
and I think that's what it was. I'm sure it was the it was something to do with what it was going to do.
Yeah. Like a functional testing is you test the function of the system, and non-functional is that how it behaves.
Yeah. Okay. Yeah.
Like availability, accessibility, load testing, stress testing.
So
Because
yeah.
load testing is, for example, if the system allows you to access 100 records, yeah, in 5 minutes, yeah, then when you really try to access 100 records, then you seen whether it took 3 minutes or 6 minutes.
Okay.
Yeah, so that's basically the non-functional testing. Let's say latency, the delay, these are basically the non-functional requirements.
Yeah. Okay.
Yeah, so there isn't too much about that's not difficult to understand the testing. Only four things needs to remember: the black box testing and white box testing. I told you the difference between them. When it says white, then you look at every component. When it says black, then you check the system as a whole. When it says the functional testing, means you want to test each and every component. And when it says non-functional testing, it means you executed the system and you observed the behavior, that how it was.
Okay.
Yeah, so that's about the third learning outcome today. And I had splitted the third learning outcome in three parts. So we discussed the first part, which was about the reviews of the database, and the second was based on the data dictionary, yeah, and third one was based on the the testing.
Yeah. Okay.
Yeah. So, and superficially, if we think about the reviews, yeah, then the reviews are obviously looking at in the architecture and its implementation, and in the data dictionary wise, you look at the how structurally they have been designed into the system. You should be able to know certain commands, and the testing is basically you need to test the system one by one or as a load by giving the load to the system. That's it.
Okay.
Yeah, is that clear?
Yeah. Yeah. That's clear. Yeah. I'll by the time I come to do the assignment, I'll need to look over it again anyway. But yeah, I'm clear with that.
That's fine, and you are always welcome to ask any question next time. So we end up
Yeah.
this session now, and we will schedule the next session. I'm not sure. Can we have a session if you want on the weekends?
Yeah, I can do Sunday night.
Sunday night. Okay, let's see. That how the Sunday goes. I mean, what are the things to do for myself on Sunday, and then we'll let you know on the Sunday morning. Yeah.
Yeah. Okay. Yeah. If not, we'll do it in the week.
Yeah. Okay, that's fine. Yeah, I will let you
Okay.
know. Okay.
Okay.
Thank you.
Cheers.
Bye.
Cheers.
Bye.
Bye.